area network. Okay, so a LAN, which is explained in your textbook already, you can look it up, local area network, is the smallest unit of networking. In other words, as far as TCP/IP is concerned, if you want a computer to talk to another computer using TCP/IP, you have to have a LAN. Okay? Even for a computer to talk to itself, you need a LAN. Okay? It's just that it's a very special case of a network, but a computer can talk to itself. And there are occasions why you want a computer to talk to itself. Okay? And I'll explain that later when we get to computer client programs versus server programs, because that's when we will talk about, oh, but how come we want this computer to talk to itself? Well, because it is useful to talk to itself. Okay. All right. So the one thing we have to know is a LAN has its own address. So this is called a network address. This part is similar to an area code. Okay. What do I mean by area code? I mean, let's forget about networking. What do you think an area code, why is an area code important?
So you can send a letter for whatever you're sending to a specific area without having to make a really long code for every specific house or location.
That's a zip code.
That's a zip code.
That's a zip code, but it's similar.
Yeah.
Okay, this is similar in terms of concepts. Yep.
So you can reuse other numbers for different areas.
Aha, very good. Hey, so he just hit the nail. Because if we're talking about 916 as an area code, if your phone is within the 916 area code, do you have to dial 916 when
No.
you're calling another number of the same area code? No, you don't, right? But for someone outside of the area code 916, they do have to dial 916 as an area code because they're out of the area code. Okay. It also helps to make it easy to understand which part of a phone number is the area code and which part is the phone number within the area code, right? You look at the phone number 916-484-8250. This is a quiz of my syllabus because this is my office number. Okay, so this part is the area code, and this part is the phone number within the area code. Now, if you want to chop it down even more, you can actually chop it down to this part is my extension number. If you're inside the district anywhere, okay, it can be another campus, you pick up a campus phone, you can dial 8250, and it will get to my office. Okay, even if the other school, like in Folsom, is not having the same does not have the same 484 prefix. Okay, just dialing 8250 will get to my office. Yeah. So the entire district shares up to 10,000 numbers because the last 4 digits are the same. Or they only change the last 4 digits of those phone numbers. Okay. And with networking we have a similar concept. The network address is your area code. Okay, so a LAN has its own address, a network address, and this part is similar to an area code. All computers, okay, I will put computers in quotes at this point, okay, because this is what we most commonly think of networking, because we say, oh, a computer is on the network, another computer is on the network. This computer wants to talk to the other computer through the network. So we'll use computers, but in quotes, because later on we'll find out that, oh, but that's not exactly the right term to use. But we'll deal with that later. So right now I'll put it in double quotes just so that it is a reminder to say that later on we'll clarify what exactly we are dealing with here. Okay, so all computers within the same LAN have addresses that start with the same bit pattern. Okay, since we have already talked about binary numbers, we can talk about what is a bit. A bit is a binary digit. Okay, what does that mean? That means when you set up a network at home, okay, you go to Fry's, you bought a router, okay, you buy a residential gateway. There are many ways to call those things, or you just buy one from AT&T. Okay, you have it installed at your home, and you decided I don't really just want one computer to be able to go online. I want the entire family to be able to go online all at the same time. So in order to do that, you have to have a local area network so that all the computers are networked and they all go through the router to go outside. So in that case, you have a network. With any network, you have to have, with any computers on a local area network, it has to have an address. And the address has two parts. It has the network address, and then it also has the node address. Okay, so the node address is the other part of an IP address besides the network address. Look at this as the number, as the phone number to the right of the area code. Okay. In other words, 916 is my area code. It is my network address. 484-8250 is my node address within that area code. But my complete address, my complete phone number, is neither this nor that. My complete phone number is 916-484-8250. Okay? Is that okay? Working out so far? Okay. So in terms of networking, it is almost exactly the same thing. Okay, so I'll just use an example here. 916-484-8250. So in this case, 916 is the area code, which is my network address. 484-8250 is the phone number, which is my node address. However, 916-484-8250 is the complete phone number, which is an IP address. Okay? Is that okay so far? An IP address has two parts. One part is the network address, which identifies the local area network that the computer belongs to. The other part is a node address, which identifies the computer within that local area network. Okay. Do we have any questions so far about this example? So I'll use a bullet points to make it stand out a little bit more, like so. No questions? Okay. Now we want to take a look at some examples. Okay. Most home routers default to use 192.168.1.0 as the network address. Okay. So with that network address, this means computers in the network typically have addresses like 192.168.1.1, 192.168.1.2, and so on. Okay, does that match your experience when you set up a home router? And in fact, 192.168.1.1 designates the router itself. Okay, if you point your browser to 192.168.1.1, it does not go outside to the internet. It connects to the router. It gives you a screen to log in, and once you log in, you can do all sorts of administrative work like MAC address filtering, or how to call it, access control. You can configure the routing. You can configure a lot of other stuff for your router. So most computers will start with 1.2, 1.3, and so on. And depending on the brand, some brands may even use 192.168.0, 1, 0, 2, 0, 3, 0, 4, and so on. Yep.
Who does, where does the 192.168 come from? Why isn't it just 1, 2, 3, 4, 5?
Aha, very good. Okay, that's a very good question. The 192.168 prefix means the network, the local area network, is a private network, which means this address will never be seen by other computers on the internet. It can only be used before you move into the internet. So we'll explain why your computer can still hook up to the internet. Okay, because your router is a special device. Okay, it can talk to both sides. But we'll get to that part later. Are we okay so far? Yep, go ahead.
So in your analogy with the phone number and everything, you know, with because there's 4 in an actual IP, which part applies to the actual IP?
That's a very good question. In fact, that is the reason why we have to introduce binary numbers. Because the boundary between the network address and the node address is not always landing on a dot of the 4 number representation. Okay, the 4 number representation is just to make it easier for people to read out an IP address. Okay, so that's a very good observation. A IPv4 address is a 32-bit pattern. Okay, in other words, each IPv4 address has 32 bits, or 32 binary digits, which is pretty long. Okay, you have to spell out a lot of zeros and ones. Okay, the boundary between, or the boundary separating the network address from the node address can be on any bit. Okay, so that makes it really tricky because each of the numbers that we know of, like 192.168.0.1, each one of those numbers is an 8-bit chunk already. Unfortunately, the boundary may not be at an 8-bit boundary. So that's why we have a concept called a net mask, which is basically a pattern of ones to indicate which part of an IP address is the network address and which part is a node address. Now that's way kind of beyond what we need to go through in this class. So for our discussion, we'll just say that it's always landing on an 8-bit boundary. So that way, when we look at 192.168.1 something, we'll always just say that the last digit in this case is the one that is the node address within the network. Okay, but when you take a networking class, then you will realize that boundary can be anywhere within the 32-bit. And that's why we have a concept called a net mask to indicate which part of the 32-bit pattern is the network address and which part is the node address. Okay? Okay. Any other questions? Okay. So, but after all this discussion, all IP addresses within the same local area network must have the same network address. Well, that makes sense, right? Everything within the 916 area code area must have a 916 area code. Okay, it's kind of like a self-explaining kind of thing. Okay. Now, what this means is, if you have to assign static IP, in other words, if you cannot rely on a computer to ask a device to say, what is my IP address, and instead, you have to assign the IP address to computers inside a local area network, you have to play by these rules as well. You cannot just say, oh, you are 192.168.0.1, and you are 198. You are 1.2.3.4. Those two computers cannot talk to each other because they are on the same local area network physically, but the addresses do not share the same network address. Okay? So you have to kind of remember that sort of thing, but I don't think most of you have to assign static IP to your computers. Okay. Any questions at this point? No? Okay. So a private network